There we go. All right, so we're going to go over points, lines, and planes today. Those are the undefined terms in geometry. So again, undefined terms in geometry are points, lines, and planes. Okay, so they have no size or shape. Okay, they don't have any size or shape. You might think, oh, well, I can make this point larger or smaller, but a point is just a location. So they are a mathematical idea. And they are explained using examples and descriptions. Okay, so we're going to go through each of these undefined terms. So starting with a point, the description of a point, it has no shape or size. It is a location. Did I spell it right? Yeah. And is represented by a dot. Okay, so it's where something is located. You place that point there. So how to name a point? It is named with a capital letter. Okay, so do not use lowercase letters to name points. There's an example off to the right there. Here's your dot for your point, labeled with a capital A. We call that point A. Okay, so if I had another dot here, say I label it C, make sure it is a capital letter. I know it's hard to tell with C's. I would say this is point C. Okay, our next undefined term is a line. Okay, so a line is made up of points. Okay, it has no thickness or width. And through any 2 points, there is exactly one line. Okay, so if you have 2 points, you can only draw one line through those 2 points. You can't draw multiple lines through those 2 points. Okay, if you overlap the lines, that's still the same line. Okay, just because you're redrawing over it multiple times doesn't mean there's multiple lines on top of those 2 points. Okay, so lines are named using 2 points on the line, meaning you have to use those 2 capital letters, or a lowercase script letter. Okay, lowercase script letter is a cursive letter, like L, M, anything like that. Usually you see L and M the most when we're dealing with lines. So example, I have a line drawn in here. So our first way to name that would be using 2 points. So I can place 2 points on my line. I'll call them points A and point B. Now when I'm actually writing out a line and I want to say this is line AB, I would use my capital letters from my points. And you do have to draw a line over the top so that we know it is a line. Okay, and a line has arrows, so don't just draw in a segment. You have to draw in those arrows at the ends. Okay, so this would be line AB, or you could switch the letters around and it's the same line. Okay, if you're using a script letter, such as L, usually you'll see that off to the side of the line. Okay, so it won't be within the line. You'll usually see it drawn or written off to the side, so up here or over here. So this could also be line L. So that's how we kind of name our lines. Any questions so far? Okay, our last undefined term is a plane. Okay, so a plane is a flat surface made up of points that extend infinitely in all directions. Okay, so your plane is like a flat piece of paper here that keeps extending in all of the directions that it goes. Okay, so it can be sideways, it can be flat, it can be vertical, anything like that. So through any three non-collinear points, there is exactly one plane, and I'll get into what non-collinear points are in a little bit here. Okay, so through those 3 points, there's exactly one plane. Now to name a plane, we can use a capital letter in the corner, so again we have these capital letters, or we can use the 3 non-collinear points. And I'll show you that off to the right in that example. So they're saying this plane would be plane X. So since they're using that capital letter, we want to put that X in one of the corners. Now it doesn't matter what corner you put it in, it's just in one of the corners of that plane. So when you draw a plane, it's kind of like a parallelogram. That's how I usually draw them. But again, they do extend infinitely. So these sides will keep going. We just need it to look kind of concrete as we draw it. Does that make sense? Yeah? Or we can use our points. So I can put a point in my plane. I'll call it point A. Put another point in my plane. And I need one more. So you always need 3 points. Okay, and those 3 points cannot create a straight line. Okay, so those 3 points should not create a straight line within your plane. So this is plane X, or I can use my 3 points that I just drew in. So I can say this is plane A, B, C, or any combination of those capital letters. Okay, so or I could say this is C-A-B. Okay, so any combination of those 3 letters within that plane to name it. Okay, questions? All right, so I have some vocabulary here at the bottom. Okay, first one is collinear. Okay, you do have to know what collinear means. So collinear is when points lie in the same line. Okay, so they'll all be in that same line. So if I have a line, all of your points have to lie on that line. Okay, you can't have one floating away from it. So then non-collinear are points that do not lie in the same line. Okay, so here if I have a line again, I have 2 points on that line. This third point over here, all 3 of those points are non-collinear. Okay, so they don't all lie in that same line. Okay, next is coplanar. Those points lie in the same plane. Okay, they're points that lie in the same plane. So coplanar has to do with planes. Collinear has to do with lines. Non-coplanar are points that do not lie in the same plane. Okay, so you can have multiple planes. Like this would be a plane. It's really hard with paper because it bends. So this would be a plane, this would be a plane. If I had a point over in this one and a different point over in this one, those would be non-coplanar because they don't lie in that same plane. Okay, so you have to think about it 3-dimensionally here when you're working with planes. Any questions on that so far? All right, so we are going to look at some examples here of naming lines and naming planes. Okay, so I'm going to find a couple with you, and then I'm going to have you guys work together in your groups here to find the rest. So number 5, we want to name a line containing point W. So in our picture to the right, point W is right here. Okay, so I want to name multiple lines that are the same here. So to name a line, we need 2 points on that line. So since point W is on this line here, I could call this line VW. So I would say VW. And then I do need to include my line above those two letters. Okay, so that's one way. Another one, I could take W and a different point within that line. So I could say this is line WX. Okay, I want you guys to find the other 4. Okay, so talk to each other in your group, find those other 4 ways you could name this line.
Can we do like XV?
XV, yeah, you can do XV. All right, what's another name for this line? WV? Yeah? WY? What's another one that I know all of you missed? Think about it. What's another way to name a line without points? This is also line N. Okay, so you can name it using that script letter. Make sure you are just using 2 letters when you're naming lines. Okay, you shouldn't use more than 2 letters. Okay, so just 2 letters to name a line. Now, naming a plane, that's when you use 3 letters. Okay, so that's what we're going to do next. So we want to name a plane containing point X. Now, to name a plane, you need 3 non-collinear points. So they can't all lie in this same line. Okay, can't all lie within one line. So to name a plane here, what I could do is say X, W, and then Z. Okay, so you can see how they kind of make that triangular shape when you're naming a plane. So I could say this is plane X, W, Z. Okay, I could also say this plane is XVZ. Again, you can see that triangle pattern created between all of those points. Another one, let's start with y this time. If I go y, z, x, right? Those are 3 non-collinear points. All right, I want you guys to do 3 more. All right, what's another combination of letters here that I could use to name a plane? I don't have written. Z, V, Y, yep. It's another one. Yep. T, W, X, yep. And plane P would work too.
Don't all the points have to be in the plane?
They don't. It's a good question. Bye.
Just wondering. Do you feel about having one more student in this class? Could we do that?
Oh.
Yeah. It doesn't work in her schedule for your other sections that are open.
Yeah. Yeah, that's fine.
Also, she maybe has failed and
Okay.
the parents are really on board and she has made some changes in her school.
Okay.
So we're gonna give it a shot. Is that okay?
Yeah.
Please say that.
Okay.
I'm gonna send her down.
Okay.
Okay, thank you.
All right, so I want you to look at this next question here if you're confused why I did this one, TWX. So this question asks, is there a plane named WTX? Okay, so WTX. Those 3 points are non-collinear, right? Yes? They're not all in the same line. So yes, we can draw a plane through those 3 points. So just because it's not drawn in our picture doesn't mean it's not there. Okay, so yes, you can create a plane through those 3 non-collinear points. Now sometimes it does ask you how many planes are drawn in a picture. That's when you only look at the planes that are drawn in, okay, not create your own. In this one, it just is asking for a plane containing point X. Okay, so as long as that plane contains point X, you can just use 3 non-collinear points to do that. Questions? All right. So next here, we want to name the geometric terms modeled by the objects in the picture. So push pin. If we have a push pin, what would that model? A point, a line, or a plane? A point. The edge of the bulletin board, not the entire bulletin board, just the edge would be a line. And then this card over here would be a plane. All right, next we're going to talk about intersections. So the intersection of 2 or more geometric figures is the set of points they have in common. So both figures will share these points. Okay, so both of your figures, if it's a line and a plane, or a line and a line, or a plane and a plane, they will share that set of points where they intersect. Okay, so what we're going to do next is actually draw different points, lines, and planes. And I'll do some with you just to get the hang of it here. So our first one, we want to draw in two intersecting lines. Okay, so we'd have one line and then a line that intersects that line. So two lines should only intersect at one point. Okay, so two lines should only intersect at one point. And that would be this point here. I'm just going to label the intersection so you know where it is. Okay, so they do only intersect at that one point, that point X. All right, the next one we have is a line that intersects a plane at point X. So to draw in a plane, that's what I want to draw first. I'm going to draw this parallelogram. There's more sheets right there. Yep. Okay, so this is my plane. Again, a plane extends infinitely in all directions. Okay, but we need this finite space so that we can actually draw this intersection. So since this line is intersecting our plane at point X, I know point X has to lie on my plane because it's that shared point of that intersection. Now I want to draw a line that goes through my plane. Does that make sense? So here's your plane. You need to draw in a line that goes through it. Okay, and only hits your plane at one point, and that's point X. So it is kind of hard to draw if you don't understand it. So what I'm going to do is draw part of my line straight up. Okay? Then I'm going to add in this dashed line through my plane. And then extend it the rest of the way down so that you can kind of see it going through it. Where that dashed line is, it's on the bottom half of your plane. Think about it three-dimensionally. Do you kind of see that? Where it would go through the plane? Kind of. So if you ever do need to draw something like this on an assignment, on a quiz, on a test, you do need to include this dashed line part to show that it's going through the plane. If it's a solid line, it'll just look like it's lying on top of the plane. Okay? Questions on that second drawing there? Again, you have to look at it three-dimensionally. Wrap your head around that. I want you guys to do this one right here. That third one. I want you to try this fourth one. And then I'll do the last two after you do those ones. So do the next two. labeling it. Don't just draw in a line or a plane. Make sure you are labeling it if it tells you to. So for the third one, yours doesn't have to look exactly like mine, as long as you understand what parallel means, okay? So they're not ever going to intersect, okay? Parallel, they're never going to intersect. You want to make them look parallel to each other. Okay, then the fourth one, we have line QR intersects plane T at point S. So I do need a plane. I always look to see if I need a plane first because I like to draw that in right away. So I do need a plane here. Okay, that plane's name is plane T, so I am going to label that in one of my corners. Doesn't matter which corner. Be up here, over there. Then I need line QR intersecting that plane at point S, meaning point S has to lie on plane T because that's the intersection point. So I know point S has to be in plane T. Now it's kind of like the second one we did now, where it only wants it to intersect at point S. So we have to draw it as it's going through the plane. So I'll draw one section up. I'll add in my dashed line through the plane and extend it the rest of the way down so that it looks like it's going straight through that plane. Now I still need to label this line QR, so I need to plot the points Q and R on my line. Okay, it doesn't matter where. I'll just choose those two. So make sure you include all of that information. All right, so for the sake of time, I'm going to skip this one, but I am going to show you this one because this one gets kind of confusing. So we have plane ABC intersecting plane ABD. So we have to draw two planes intersecting each other. Now, when I see two planes intersecting each other, I always look for points they have in common. What 2 points do both of these planes have in common? A and B. That means that that segment created at our intersection has to contain points A and B because both planes have points A and B. So to start this drawing, I'll do my first plane like normal. And I'm not going to label anything yet. Now my second plane, again, just like your line, has to look like it's going through that plane, which is kind of hard to draw. So it has to kind of look like this. My paper won't bend. Like this. Okay? So to do that, I'm going to create my other plane going up this way from both sides. Okay? So we're going to go up this way from both sides. It's going to create kind of a fan shape here. So this little line right here is that intersection of those two planes. Right there. Now I'm going to extend my plane that's kind of vertical here through my other one, just like we did the line, and then it comes out at the bottom here. Okay, over here I'm just going to extend it through the bottom, and then I'm going to extend this further, and then connect right here. So I know it's really hard to understand unless you think about it three-dimensionally. So it should create this fan shape. Do you kind of see it? Yeah? Now, this other line that I drew in right here is that intersection line. So that line needs to contain points A and B because both planes contain points A and B. So I'm going to plot point A here. That's A. Point B, right there. Now, points C and D have to lie on separate planes. So on this first one I drew in, the solid one, that's horizontal, I'll put point C.
Good morning. Please excuse the interruption. Would students with last names A through D that need to have their picture taken, please report to room 1305, which is next to the ECT room at this time. Thank you.
Yeah, if you need to go get your picture, go get it. Just with that last name. Point D will go on this other plane that I drew in. Okay? So A and B have to lie on that intersection. C goes on one, D goes on the other. Okay, questions on that? If you don't understand how I drew mine in, if you go to the next page and you look at this picture here, that's an intersection of three planes. Okay, so it does create that line and you can kind of see that fan shape a little bit better. Okay, I'll never ask you to draw an intersection of two planes on a quiz or a test. Okay, I know it's kind of hard to draw in and understand. I will, however, ask you to draw a line intersecting a plane. So make sure you know how to do that one. All right, questions on our drawings before I move on here? So space is a boundless three-dimensional set of all points. And space can contain lines and planes. All right, so in this next section here, we're going to look at this picture, and we want to decide how many planes in the figure are drawn. Okay, so we're not making up our own planes, we're just looking at the ones that are drawn in. Okay, so discuss that with your group really quick. If you have a group, since some people left. Okay, so count how many planes there are. Decide as a group what that number would be. All right, how many of you think there's 6? How many of you think there's 7? Okay, there are 6 planes. This bottom one right here is the same as this larger plane X. So you can't count it twice. So there are 6 planes drawn in here. So you just got to be careful of that little aspect. All right, number 11, name 3 collinear points. What does collinear mean? Same line, good. Okay, so we need 3 points that are in the same line. The only 3 would be these 3 right here. Okay, only 3 that lie in the same line. J, K, and D. Number 12, we want to name the intersection of plane HDG. So I have to find point H, then D, then G. So that's this triangular plane right here. Okay, in the front. We want to name the intersection with plane X. X is the bottom one, the flat one on the bottom. So what would our intersection be with those two planes? H and G. Now when I write this out though, it has to include that entire segment. Okay, so we're going to say that intersection is HG. Okay, not just the points H and G. Okay, 13, we want to name the intersection of line LM and EF. Talk about that one in your group. This line and this line. So what are those two lines' intersection? I'm not trying to trick you. What? Okay, they both lie on plane X. I mean, L lies on plane X. So line LM right here, that line's going through that plane, right? It's going vertical and that plane's horizontal. So point L is the only point that lies on plane X. Now if I extend this line EF and actually make it straight, these two lines are never going to intersect. Okay? So this one right here will go right past point L, and line LM is vertical. That one's horizontal. Okay? Those two lines will never intersect. So this would be none. There is no point of intersection. Okay, again, you have to think about it three-dimensionally. Okay, this is the last one I'm going to go through because the other ones are pretty similar. So we have E, D, F, and G. Are they coplanar? Okay, so do they all lie in the same plane? So point E, D, F, and G. Are they all in the same plane? No. Okay. E, D, and F make up one plane, but if we're looking at just that plane, point G is not going to be on that plane. If I look at D, G, and F, but then point E is over here, there's a plane here, but point E wouldn't be included in it. Okay, so no, those points are not coplanar. They do not lie on the same plane. I lied, there's one more in this section. So 15, name the intersection of planes JDH, JDE, and EDF. Without looking at the picture, what's their intersection? All of them include point D. You can use a picture if you didn't understand how I did that. So, again, just looking for each of those planes, they all intersect at one point, and that point is D. Okay, do you guys have any questions on points, lines, and planes, how to name them, how to find intersections, stuff like that?